So good afternoon and welcome to the 28th annual exhibit of hydrogen fuel cell technology. That says a lot, 28 years in the business. We've always been discussing where the hydrogen and fuel cell industry is going. I always start the elevator pitches with a short note on the history of electrolysis here on the fair. If you go back 15 years, the space occupied by electrolysis at this fair was pretty close to zero. It was all PEM cells and what they're doing. And all of a sudden, in the past 6, 7, 8 years, electrolysis has become the major occupier per square meter of space here. What that means is there are business models. What that means is we've recognized the importance of harvesting renewable energy, but how do you do that without electrolysis? Without the ability to convert water through electricity into hydrogen, we are standing in sand. So this format, the elevator pitch, was part of the discovery of how to get a conversation going about electrolysis and its future in the energy equation as we transition towards renewable energy. All of you should come forward, by the way, and have a seat. We will be serving drinks during the presentation. Better than that, for those presenting and for those listening, if you hang around, and this is going to continue until about 4:30 or 4:45, you will be served wine and beer on the house. This is also exactly applause for that, yeah. So don't miss that. It's a very important element. There's hydrocarbons there, so it's also one of those luxuries of this format. This format involves elevator pitches, 7 companies, one after the other, the biggest players on this exhibit, and they're going to introduce their technologies. Sometimes it's going to be technical, sometimes it's going to be straightforward. The alternative aspects of these electrolyzer companies will be highlighted, their different technologies. But what is really interesting is we get the conversation going afterwards. All 7 of these big players are going to discuss with us how we are going to transition to renewable energy from the egregious position we're in right now, where the energy supply of, among other things, natural gas is dependent upon an autocrat. That's where we're stuck right now, and that's the situation we need to get out of. I will not introduce all the guests one after the other right now. Individually, as they come to the stage, I will present them, and then at the end, we'll gather together on the stage, we'll address each other's topics, and we'll invite you to participate in the conversation. Is that okay? Okay. And yes, the wine and beer are coming. So, but first things first, Matthias Kramer, who is CFO of Hoeller Electrolyzer, will come up and present his company and his technology. Welcome, Matthias.
Thank you. Thanks a lot for the opportunity to introduce you to Hoeller. We are a reasonably young company, about 5 years old, and we've set out on a mission to reduce the production cost of green hydrogen. €4 per kilogram is a number that seems almost outdated with all the new numbers we've heard from around the globe, but I think for continental Europe that's still a valid target to reach. We focus on the stack. We do stacks for PEM electrolyzers only. We are not providing entire systems. And we do so with a number of innovations that we have introduced into our system. In total, we have about 14 patents filed to improve the design of the stack and the cell, all with the goal of improving efficiency and bringing production costs down. We believe that despite the fact that electrolysis is an old technology, if you want, there's still a lot of room for improvement. And the second lever that we pursue is to go into volume production to bring the cost of the system down, because at the end of the day, that all needs to come together to make green hydrogen more competitive than it is today. We are focusing on 2 products, a small stack called Prometheus S, which is a 100 kilowatt version, and the larger brother or sister, which will provide or can consume up to 1.5 megawatts. Are they available as of today? No, they are not. They go into prototype testing in August, and towards the end of this year, we'll be ready to supply the small stack to the market. Thanks a lot, and I think all the questions we do later.
So thank you. vorbildlich, as one says in Germany. We're restricted to 3 to 5 minutes for these presentations. It's going to go quickly. Second up on the stage is Dr. Max Ellerich, who is Technical Director at NEA Green, Neuman and Esser. Max, are you in the room? Yes, you are. Welcome, Max.
Hello together. My name is Max Ellerich from Neuman and Esser, and so in contrast to Hoeller, who's focusing on the stack only, we are focusing on the system only when we are dealing with our electrolyzers. And our electrolyzer system is a customer-centered standardized solution where we integrate also the compression, of course, because you have to know about the history of Neuman and Esser. We are a 190 years old company doing hydrogen compression for over 100 years and are very experienced in building systems, especially hydrogen systems around that. And by leveraging that know-how we have from our compression and hydrogen side, we right now also offer an electrolyzer where we integrate stacks into an entire system that can be dedicated to several industries, like especially mobility and furthermore industrial applications. That means we consider the system in its context and its surrounding. So what are the requirements of a mobility application towards a decentral or even an on-site electrolyzer? So you want to inject tap water and electricity and get out the hydrogen at the right purity and the right pressure. So this is what we take care of. We take care of the entire system. We take care of the right purity for SAE protocols, for example, when it's about mobility. And furthermore, what we do is with our digitalization platform, which is NEA Explore, we also can control, remotely operate, remotely maintain, and remotely control the entire system. So, and again, also here, we think what might your requirements be if you have a decentral electrolyzer standing around somewhere, and this is exactly where we bring all our competencies into play. So Neuman and Esser has an international footprint. We have sales and application centers across the world, whereas we see a high focus on the electrolyzer market or in the hydrogen market in general within the center of Europe or within Europe in general. So this is why we are serving this market first. But next to our sales centers, our service centers are also able to maintain the electrolyzers where they are needed. And by the standardization of the overall product, so we are about to establish a factory where in several years we will build one electrolyzer per week, and by standardizing and modularizing this product, we want to come into the broad field, and we want to serve every mobility application with one of our electrolyzers, because especially when we come to heavy duty mobility, buses, trucks, several tons per day, we think it's quite crucial for you to have an on-site production, and this is exactly our offer, and I think it perfectly fits to Hoeller's stacks that could be integrated there, for example. Thank you very much.
Thanks, Max. So up, we're shifting up the order. Vaitea Cowan, co-founder and head of communications at Enapter, next up on the stage. Welcome, Vaitea.
Hello, everyone. Good to be back. Good to see you here. So, yes, my name is Vaitea, one of the co-founders of Enapter. And Enapter is a global energy tech company. So we're designing and manufacturing the AEM electrolyzer. So we're in serial production right now in Pisa, in Italy, and we're going into mass production in NRW, which is in Germany. We're a team of close to 250 today, so that's huge, fast growth since we first started in November 2017. And we're working towards making green hydrogen affordable and accessible for everyone. So I wanted to start off by looking at where is hydrogen already being used today, where are our applications today, because hydrogen is now and it's happening. So we're starting off here, actually just in Germany. And this is our partner, JAG Technology. And they've integrated 30 of our electrolyzers into a container that has multi-purpose refueling. And here you can see that they're using it for refueling forklifts. And JAG is a gas application provider. Next up is another containerized solution. It's the same size, it's 100 kilowatt, and this is actually in the UK. It was ordered by an energy developer called Green Protium Solutions, and then integrated by Fuel Cell Systems. And I mean, it looks pretty cool, right? And last but not least, in the mobility sector, we have here our electrolyzers producing 11 kilograms of hydrogen a day for our customer Zeravia, which are currently testing their 20-passenger aircraft. So yes, hydrogen planes is a thing. Switching to another sector, the industrial sector. So here we can see 21 of our electrolyzers producing hydrogen on site, and this hydrogen is used to create green ammonia. So this is taking place in the US, in Colorado, from one of our partners called Starfire. And last but not least, we're also active in the energy storage space. This is a remote village in Malaysia, and if you Google BBC Enapter Malaysia, you can watch a short documentary about it. So to this date, we've sold over 3,000 systems, and we're already present in more than 49 countries so far. So we've got a global traction, and our customers, as you've already seen a little bit from our use cases, are system integrators, EPCs, project developers, IPP. They're really all across the globe. And why are they working with us? It's because we're making our systems easy to use and also have a quick delivery. What's our secret sauce? Well, it's the AEM technology, which stands for Anion Exchange Membrane technology. And so we've already recorded thousands of hours of operating hours. And the AEM is the next generation electrolyzer technology, and Enapter is the pioneer. So when you think of the AEM, it's bringing the best of the PEM and the alkalines technology. So we've got low cost, high efficiency, and also dynamic response. So at the core of our electrolyzers is this core AEM stack, and it's the foundation for all of our products, from the kilowatt range to the megawatt range. And so here we've got our standard kilowatt electrolyzer generating 1 kilogram of hydrogen a day, and it's our single core. And then here we've got our megawatt scale electrolyzer, which has 420 of these core AEM stacks, producing 450 kilograms of hydrogen a day. And the first commercial delivery of this AEM multi-core is scheduled next summer, 2023. And so we're taking these core stacks and other components of the electrolyzer into mass production. And we believe that by focusing on one single core size system, we can reduce the price of green hydrogen much quicker. So instead of building larger electrolyzers that are complicated, sophisticated, engineer, and just take a long time and really built as projects, we're focusing on building electrolyzers as products because it's quicker to produce and to build. And so we're building compact systems that can be combined to achieving any hydrogen quantities needed. And in the spirit of urgency, we've also developed our energy management system toolkit, which enables remote monitoring and control. And it's our software that enables any integrator to quickly integrate their electrolyzer into any energy setup and enables the communication between the different energy devices, no matter where their manufacturers are from, because of course in an energy setup, it's not the same manufacturer. So when you ask about, okay, so then what's next? It's going into mass production. And this is an image of our Enapter campus currently being built in northwest of Germany. And this picture is just from last week, end of May 2022. You can see here our production hall and then behind the R&D building being built. And this is where, in the first phase, we will have 10,000 units produced each month. When it's completed, this is what it will look like, and we're expecting to have our soft opening and launch beginning of 2023. And as you'll notice, it's fully covered by solar panels because we believe that going into mass production does not need to come at an environmental cost, so our mass production will be fully powered by green energy. And you can also guess that if we're building such a big campus, we're also looking for a lot of people to join us. So check out our openings because we're looking for a lot of new colleagues. So if you're looking to fight climate change with urgency, Enapter is your technology provider. Thank you.
Yeah, thank you so much. Up next on the stage, we're going to be talking to Ulf Jörgensen, who is from H-TEC Systems. Ulf, join us on the stage. Welcome.
Thank you very much, Brian. Yeah, I'm here to introduce H-TEC Systems to you and have a little overview of what we are doing, where we do come from, and what our partners are doing. And yeah, where do we come from? Let's start with that. We've got 36 years of experience for building fluid systems with oils, gases, pressurized air, and everything else. And for us, we started in 2019 with hydrogen as it's only another fluid for us. So coming from the production, maintenance, servicing, and installation commissioning of fluid systems, we could rapidly start to integrate Enapter's modules to set up complete hydrogen and energy systems by scaling them up and using their modularity and their innovative AEM technology, easy to integrate and combine with fuel cells, storage, compression, and everything else that's needed for complete systems. So that's what we are focusing on. And we're doing that with a mission and background. We want to speed up energy transition. As we all know, that's definitely needed, and we need to be as fast as possible. And that's why we are strongly cooperating with partners all over the world, integrating systems, producing for them that they can realize projects all over the world. Use cases like energy storage, like chemical processes, remote area supplies, energy backup, whatever else is needed from really small scale like 2.4 kilowatts where we start with the Enapter modules and scaling up to megawatt class. We are the ones that sold the first megawatt scale multi-core from Enapter and are very happy when we'll install it and commission it next summer. So we'll be very happy to talk about that later on. And we're always on the lookout for partners who want to join us on the mission to speed up their sales by using us as their workshop. We are strongly cooperating and always on the lookout for partners coming from, let's say, energy planners like construction bureaus, like EPCs or whatever. All those guys who do the planning and know the technology, know what's needed, know the energy amounts that are consumed, but strongly need someone to build up the systems very quick and easy. Most of the components are on stock and can be delivered very, very fast. So we would be very happy to join to see you joining us on C56-1 right behind the Enapter booth, and yeah, we'll be happy to hear from you. Thank you for your attention.
Thank you. So up next on the stage, Alexander Detke, who is Technical Sales Manager at H-TEC Systems. Alexander, welcome.
Thank you very much. Thanks. I'm happy to be here today. And I would like to start with a little question. What do we all here have in common? I think we all here have in common that we want to fight climate change. And that means to reduce CO2 emissions all over the world. And as well, we as H-TEC do. We have an ambitious goal. It's to reduce the CO2 emissions worldwide of 1%. And how do we do that? And who are H-TEC Systems? We are a leading PEM electrolyzer provider, and we are established in Germany, and we are on the market since 25 years, and we focus on development and producing of PEM electrolyzers and PEM stacks. And we are a 100% daughter of MAN Energy Solutions, and as well thereof part of Volkswagen. We are focusing on nearly every market you see as well here, so mobility at first, but as well industry like chemical, steel, refinery projects, but as well energy storage, for example. yeah, we have what it takes. What makes us special? Firstly, we have experience of 25 years of PEM electrolysis and stacks R&D, and we are we are part of MAN and Volkswagen. We are dynamic and we are fast as well in decision and in serving you as our customers. Moreover, we have the EPC capability for large-scale projects in using the MAN know-how within our company. And as well, we have a worldwide service network and as well service. We think that's as well a core USP of H-TEC because we are near to our customers with our worldwide service network with MAN PrimeServe, for example. And we all know in the future it has to come to, let's say, upscaling of the production of electrolysis and as well of stacks. And therefore, we have the Volkswagen Group behind of us, which have the long years experience in serial production. And therefore, as well, we will open a Gigafactory within the next years to follow that route. Yeah. What's our offering? We have a really wide offering. We started in 2017 with the first stack, industrial stack. It's the S450. In 2019, we started with our ME450. It's the 1 megawatt electrolyzer for the industrial segment. And it has a production rate of nearly 0.5 ton. Of hydrogen per day. Here at the Hannover Trade Fair, we are launching our new system. It's the so-called Hydrogen Cube System, HCS. It's a modular system where you can scale up your production as you want. So we're really flexible in that, starting with 2 or 4 megawatt and then up to 10 megawatt in containerized solutions. Within the future as well, because we have much power, we next year will launch our new system. It's then not containerized. It is a system with a building surrounding, and then it's from 10 megawatts up to 50 megawatt, and yeah, we're happy about that. That's just a small slide of HCS and how it looks like. You see that we have some optionals as well. So if you have tap water, we can use it. If you have deionized water, we can use it. If you want to have 3.0 quality hydrogen, it's okay for us. If you would like to use it in your fuel cell and need 5.0 hydrogen as well, we can do it with our plant. And we can up and downscale as you want. Okay, thanks, and welcome you on our booth here at D37. Thank you.
Thank you, Alex. Up next on stage, Stéphane Maillard, I'm hopefully pronouncing it correctly, who is Sales Director at Elogen. Bienvenue.
Hi. Good afternoon, everyone. Very pleased to see you today. I'm Stéphane. I'm the Commercial Director of Elogen. Oh, no, it's the wrong one. Wrong slides. I can try to do the slides from Hector, but... Okay, this is the good one. Okay, so Elogen is the French PEM manufacturer. We have been active for 15, 20 years. We are located close to Paris. We develop stacks, electrolyzers that we supply to the customers. We are a company of about 60 people currently and growing. and production capacity equivalent to 1 gigawatt by 2030, thanks to our H-TEC project, where we'll have a gigafactory of stacks located in France. We supply stacks is the core of our technology, so we produce the stacks in our current factory, and then we supply containerized solutions to the customers as a turnkey, or together with EPC companies, we partner for larger scale electrolyzer plants of above 20 megawatt typically. So we cover the whole range of electrolyzers. And in terms of application, obviously, we do work on mobility, gas to power. We have a few methanation projects, power to power industry, and all this we partner with friends. We consider that we are stronger together, so we work with specialists in each sector, like in the steel factory, in the steel production, in the chemical production, so that we have a better knowledge of the market, the requirements, so we are sure that we have a correct understanding and a correct product for every application. So we are active on all these segments. And in our focus for the coming years, really to accompany the uptake in hydrogen, is we consider that technology is the key, the cornerstone for the development of hydrogen. So in our company, we have three main topics for which we are working on. One is efficiency of the stacks, efficiency of the electrolyzers, and especially efficiency over a large range of loads of the electrolyzer. Not just one value. Efficiency is not just one time. Efficiency is on the entire range of loads of the electrolyzer. So we focus on this, improve the efficiency of the system. Work on the aging. So work on the materials, works on the degradation, improve the lifetime of the stacks, so that you have better TCO, you have better OPEX of the projects, and flexibility. We want to produce green hydrogen. Green hydrogen means to be coupled with renewable energies. So we need systems which are highly flexible in terms of load range. So we are typical 5 to 100% of load range, fast adapting to the load variation if you're coupled directly to wind, for example. And as I said, good efficiency all the time. Good efficiency at 10%, 20% load, 50%, and of course nominal capacity. So that's the key focus of the company in terms of electrolyzer performance. And this is accompanied with, of course, massification of the production. So today in our factory close to Paris, we're able to produce 160 megawatt equivalent of stacks. It's a new production line that we just commissioned early this year with a clean room, state-of-the-art equipment to assemble the stacks and provide good quality equipment. But this is just the first step. In 2025, we will launch our gigafactory in Vendôme, in the center of France. This is part of a H-TEC project. Production capacity will start with 1 gigawatt of stack in an automated factory, and with possibility, of course, to ramp up the capacity over the years. Thank you. Happy to welcome you on our booth. We're on the C31.
Thank you, Stéphane. Up last but not least, Hector Maza from Plug Power, neuerdings, as we say in German. Welcome, Hector.
Thank you very much. So I hope I get to see my slides instead of somebody else. There you go. I'll try to go fast. I try to put a lot of images here to make it a little bit easier at the end. So Plug Power, where do we come from and how big are we? We're one of the longest standing players. For about 50 years now, we've been developing PEM, electrolyzers, stacks, and then systems, of course. We joined recently Plug Power, that was our previous company, which has been in the market for 20 years now, selling electrolyzers and fuel cells, of course. Some of you have known Plug Power for a long time for our forklift truck applications, which is material handling. We put fuel cells into those forklift trucks, and we run like crazy all day long for Amazon, Walmart, many others that you see here. We have a very ambitious plan for 2024 and even more so after that. And we have been doing quite a bit in the last 2-3 years that we have been absent from Hannovermesse, just like the rest of us. We consider ourselves to be the leader in green hydrogen. We focus on the molecule. We do everything for the molecule because we use the molecule, just like many of your customers. This is the Gigafactory we inaugurated last year, and we did a soft inauguration. We're going to be doing a real big one this year. We have 1.5 gigawatts of capacity per shift in this facility, and that's mixed electrolyzers and fuel cells, both PEM. We have a very keen eye for detail. We started with a kilowatt scale. We did 20,000 units of those. Then we moved on to hundreds of kilowatts, then megawatts, multi-megawatts, and now gigawatts. So these are the main products that we're focusing in today. Of course, our 1 megawatt platform. I hate to talk about megawatts, I'm sorry. We produce hydrogen, not power, although plug power also does power. But in the electrolyzer side, we actually produce 425 kilograms per megawatt. But just to make it simple, now we're going to talk about 1 megawatt, 5 megawatt, 10 megawatts. So it's basically our half a ton, 2 tons, and 4.25 tons per day. These are easy modules that you can adapt and just build on. And you'll see it in some of the applications. So we started a couple of years ago. The previous company that was acquired by Plug Power sold to Plug Power the first 350 kilowatt units that went into Puerto Rico, and they're being working absolutely great. We are now launching on the 5 megawatt platform and the 10 megawatt platform, 40 megawatt plants and 120 megawatt plants. These are production facilities for us, not for a customer. We actually use that hydrogen. We're the biggest consumer of hydrogen in the US. We do 52,000 refuelings every single day. We have 165 refueling stations, which we use every single day, 2 or 3 shifts a day. Our customers don't care about hydrogen, they care about moving boxes efficiently, cleanly, and faster and better than with batteries. We replace the battery, we put a fuel cell in there, of course weighs less. You have to be careful with the weight of that thing and how do you balance it out. But anyway, we fixed that problem as well. And we have been using it for the last 20 years, moving, especially in the last 10 years with material handling and making joint ventures now. You see Vaitea here, it's a joint venture between us and Renault and many other joint ventures that we've announced in the past. We're focusing really on the electrolyzer side. This is your platform where you can build upon 100 megawatt and gigawatt scale. These are 10 megawatts put in line. We provide everything, soup to nuts. You have your transformer, rectification, generation, gasification, separation, and drying. We don't really have to do the oxo drying because it's pretty clean as it comes out. It's PEM. We don't have to deal with alkaline substances, as you will know. And it's very compact. It's only about a 40-foot container, basically 13 meters by 3 meters. That's it. That's 10 megawatts. We put a lot of this in line, and this is how we build. We call them, of course, we all have project names. So you have Pathfinder, Peachtree, and so on. These are 5, 40, and 120 megawatt facilities, and we have now Gateway with 120 megawatts. And finally, internationally, we signed a collaboration in Australia, which is going to start out at roughly half a gigawatt, going to 1 and 2 gigawatts later on. This is for their use for applications in ammonia. The top ones are, and actually the Gateway one, is for our own hubs in the US. We're building all this network in the US and now in Europe as well. The point of this is we want to make green hydrogen available cheaper than gray hydrogen. We are not competing with other electrolyzer companies. We love all these guys that just came up on top. We've been working with them for some time. We want everybody to be successful because we need to displace gray hydrogen out of the way. We hate reformers. We want to get rid of those. We are becoming more and more a molecule company rather than an electrolyzer company trying to sell a product. We're trying to sell the molecule at the right price for our customers. This is what it looks like internally. So some of you talked about stacks, large stacks. We basically focus on our 1 megawatt stack. We put 10 of them in line. That's a real picture. And this is a rendering of how it was. Sorry, we recently changed our logo, so you see a couple of logos at the same time. Don't get confused, it's the same company. These are actual pictures of the units that we sent out to Amazon earlier this year. 2 of them went already in commission. 5 more megawatts are going in line in our own facility for Peachtree, and we're moving along with multiples of those in some of the customers. And of course, in other divisions of the energy division, we have 4 divisions in Plug Power. They use our electrolyzers to generate hydrogen, liquefy it, put it in trucks, truck it around about 1,000 kilometers radius. So we can reach every single one of our customers today, which consume 52 tons per day. We're expanding that into 10 times more in the next 3 years. This is what a plant looks like. It's very small. It's actually 18 acres for a plant with 40 megawatts installed, so that gives you about 20 tons a day. Then we go to the larger plant, which is about 60 tons a day. And then you can see this unit's actually being installed and commissioned as we speak. Where are we? We're at 52 tons per day, using it every single day, commissioning and actually delivering this hydrogen at 350 bar pressure in each one of our applications. Now, in 3 years' time, we're going to be at 500 tons per day. 2030, the goal is to get to 1,000 tons per day. That's our commitment. These are the very stretched but very short-term milestones. How do we get there? So we recently signed a deal for green ammonia in Egypt, 100 megawatts. Signed it a few months ago. It'll be starting commissioning later this year. Very large plant, and I think we made a press release on that one, so you already know who they are. In the 5 sites in the US we have announced. We have not announced another ones that we're working on, which more than doubles this capacity. That's just the network that we're expanding on in 1,000 kilometers radius or 600 mile radius. 1 gigawatt mobility application. All of you know about that company. We signed that deal towards the end of last month, and we are actually moving into production to deliver in the next year. That's 1 gigawatt of electrolysis. And that's going to be, of course, power to mobility. The participation in the hubs. Some of you started before we did in the US. In Europe, you started with pledging 7 billion euros here, 9 billion euros there. The US just announced that it's going to pledge $8 billion. Dollars and euros are almost the same these days, I'm sorry. And those are going to go to develop at least 10, but possibly up to 20 hydrogen hubs. And they have multiple applications in those. We're participating in at least 10 of them. This is the infrastructure. We go from green electrons all the way to the end use. It could be a molecule. It could be moving boxes. It could be going back to power. So that's why we talk about power to power, power to product, power to gas, and of course, power to mobility. What we intend to do is full the ecosystem green hydrogen alongside with you, alongside with some of our competitors or partners. I call them all of our actually partners in a way, because we want all this industry to move forward as fast as possible. We are in booth 60. If you have any questions, my name is Hector Mas. I'm VP of Strategy and Sales, and not sales anymore, Strategy and Products. And I'd love to take your, as well as most of my colleagues will be loving to take your questions and guide you through our products so that we can actually help you out in go faster, even faster this time. Thank you very much.
Thank you. Hector, you can stay where you are because we're going to initiate the conversation here. I'd like to invite all of the speakers to join me on the stage. I know it's kind of like a firing squad, isn't it? You line up against the wall and people will be shooting at us. It makes me nervous as well. Yeah, we should have about 4 microphones and stand wherever you are. I wonder where we'll fit. Oh, yeah. You may need to pan the camera out to accommodate all of this, and I may need to jump off the side of the stage, or I'll fall off occasionally. I mentioned at the beginning, and I mean, this is simply a fact, there is no way to transition towards renewable energy and cut out the fossil fuel equation without energy storage. The renewable energy is there, but you have to be able to store it. And one of the facilities being offered by all of these people is, of course, electrolysis. Any renewable energy, well, the large share, it comes in the form of electricity, and you have to do something with it. The grid can't do it. Batteries at that scale are not possible. But did everyone understand what these people were talking about? I have to be critical about a few points here, because it's communication. A couple of years ago, we had the announcement. The phrase was common. It was here as well. For those of you who were participating in the elevator pitch in 2017, people were talking about fossil fuel parity. Now, why I think that is significant is because people are talking about, and Matthias, I'm not being critical here, but you mentioned the kilogram price of hydrogen. And yet we have Hector here saying, you know, our customers don't care about hydrogen. They want to do stuff. And one of the communication lapses that I see in this field is only the industrial users of hydrogen will identify with the kilogram price. If you're talking to politicians, it won't work. If you're talking to the general public, and this is where every once in a while people would do the math and say, oh yeah, we convert renewable energy to hydrogen, we store it, we convert it back to electricity on demand, and the kilowatt price will be, and that's something everyone can say, oh wow, this is close to what I pay, or even below what I pay, because renewables in price have dropped. So, all right, My question to all of you, and I'll start because I've criticized you for using this 4 euros per kilogram. Why do engineers insist on talking in the old-fashioned manner to the industrial consumers? Hydrogen is an industrial gas. 1% of hydrogen available, 1% of hydrogen used today is actually created through electrolysis. The growth of electrolysis is based on the need for storing and transmitting renewable energy, and it's going to dwarf the existing market of hydrogen once we get that going. So why use this old language? Matthias, forgive me for the critical question, but I have to.
No problem. Happy to take it. I think what you indicated is true. We need to somehow translate into in everyday language what we're doing, because the industrial client, and I'm very much in line with everybody here on stage, is a more educated buyer. But we need to transport it, and honestly, we also needed to make it clear to our politicians. And I think the recent swing in Germany in terms of how they think about energy supply is really devastating, because it shows a very short-sighted way of doing things. So I think it's not the 4 euros per kilogram, it's not the number of filling stations that are out in the market. I think it's a understanding that we need to move faster, and I think whichever way we communicate it best helps.
Can I add to that? To make it simple for customers who never have seen hydrogen before, 1 kilogram equates roughly to 1 gallon of gasoline, or 4 liters of gasoline, roughly speaking. That gets you 100 kilometers in a car. So if you think about 4 euros, or maybe $3 in our case, moving a car forward 100 kilometers, that's where you start competing with fossil fuels.
And as well to add, because of the difference between the price of green hydrogen and gray hydrogen, I think we also have to, let's say, rethink the price of gray hydrogen, because what's the price of gray hydrogen? It not includes the damage on nature as well, so, and not includes CO2 emissions as well. And I think in future it will be more and more, let's say, on one level, the price for 1 kilogram of green hydrogen and 1 kilogram of gray hydrogen.
So Alexander mentioned CO2 reduction. Okay, another critical question. What have the German politicians done recently? Said, we've got to shut down coal production, electrical energy because of the CO2 emissions. It's better to use natural gas. What are they not doing? They're not telling you how much methane is emitted during the production. So here is the fact. Is it true that burning coal is worse than using natural gas? No, it is not true. But if you're doing the equation in Germany and not doing the well-to-wheel calculation and saying methane vented, up to 20% of the methane used is vented on the way here, depending on your source. By the way, another lie propagated here is that what they call the dirty fracking gas created from the United States. I'm not a fan of fracking, but the fact is it's cleaner than 50% of the gas being imported to Germany from we know who, right? So another question, so why are we talking about CO2 emissions alone? If you are steam reforming or using natural gas to create ammonia or using natural gas to create hydrogen, you still are not addressing the full complication. You're underselling what your technology is doing. Why do you people do this? The politicians need to hear this. Anyone want to take up that question?
I can speak a little bit to that. I mean, I'm sure that my colleagues can do the same, but we have a calculation that considers everything when you do steam methane reforming, what you vent out, what you lose when you pull it out with fracking, and also what it takes to heat up the process, because you're going to be breaking the molecule of methane to obtain gray hydrogen by adding pressure and temperature. We calculate all of that, and that's how we calculate how many tons are really emitted by the gray hydrogen molecule, and how do we replace that into a green ammonia plant, for example. So at the end of the day, we have to be successful delivering a hydrogen molecule that could compete directly with the current price, which is not yet penalized everywhere the same, because you in Europe are ahead of the US. You are penalizing at 65, 75 euros per ton. In the US, we're doing $5, except in the application for mobility where we get $200. But we really got to get better and standardize it across the board. And we know that that price is just going to go up, 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 up. We don't like subsidies, but we do like taxes on the real nasty things that we're doing. So at the end of the day, we have to be competitive today in the US without the benefit of what you're having in Europe. We love the fact that you're moving forward with it. We'd like to do the same in the US and eventually be able to, that's going to be a great addition, and that's where things are going to really accelerate. We are getting a little bit ahead of the ball, trying to go faster because we know it's coming. It's just a matter of time. But we do calculate the whole impact that we have when we're doing steam methane reformers and when we're actually pushing all that methane, which is 30 times worse for as a greenhouse gas than your typical CO2.
But when you mentioned the penalization of natural gas in Germany, it sounds like the upside. They don't do the calculation of the vented methane.
Yep.
They talk about the CO2 emissions. Is that fair? Anyone want to take that question?
I mean, the answer is right. It's easy. It's not fair, of course, right? But also, I think within our communication, we have to replace something in the mobility or in the sectors that is already there and it is already running. I mean, we ran our cars 10 years ago as well. So we have to replace it and show to the customer, okay, this is the price for the hydrogen. And I'm totally with you. So the taxes on the fossil fuels should raise even more than in the direct comparison. It's easy to get, it's easy to refill, and it's even cheaper at the end of the day. This is the communication we need to do, and I think this is why we are also promoting our products the way we are, right?
I'm always, oh, wow. This is good for wind energy, perhaps. I'm always amazed at how things change. I referred earlier to this, the dream of every engineer when we started here 20 years ago was to have, my goodness, can you give us a little more volume? 20 years ago, it was the dream to have renewable energy, electrolysis, you have a tank there, and then on demand in a remote application. This was sort of like the pure philosophy. And in fact, years ago, you demonstrated, Vaitea, one of these systems. And then all of a sudden I realized, my goodness, you're opening up a facility the size of ITM in England. It's like, this is an incredibly fast-paced evolution, and it's obviously, well, that would be the question. It's driven by a different calculation of the demand or a different market. How did you progress so quickly in the space of, what is it? I think we've seen you here since 2014, 2016?
2017, end of 2017. Yeah.
Okay. So how do you explain the pace of that transition?
I mean, there is no other choice than to go fast, right? I think there is an urgent need to phase out fossil fuels, and that's really what's driving us. So it's putting our heads down and being really focused on driving down the cost of green hydrogen as quickly as possible. And then the only way to do this is to mass produce our electrolyzers and to actually grow the team, build more systems, and now it's really taking that next step and going into an Enapter campus. And yeah, I mean, I think we're really proud to say that in terms of the life cycle analysis of our systems, when we go into mass production, we will be limiting the CO2 footprint, right? Because the mass production is fully powered by green and locally produced energy. So yeah, to come back to your question, it's really, we need to fight climate change, and that's our mission, and nothing will stop us, and we will just keep going.
May I add some words? We've been talking a lot about huge systems like big-scale electrolyzers, which we definitely need for all industrial processes and huge mobility conversion and getting rid of all the fossil fuels in big scale. But maybe one of the main facts also for the fast pace of Enapter and all those modular systems is that those are quickly available. They can be realized in weeks instead of years. They can be spread all over the world if we have the right partners, and if the people just rethink their energy usage and say just decide today, well, we want to replace fossil fuels and gas, whatever needs to be replaced, even in remote locations where thousands and millions of small diesel gensets are wasting energy and polluting the environment without efficiency at all, and at high costs, really higher costs than every hydrogen-based and complete energy system would need. So speeding up energy transition, we've got two main factors. One main factor is the size of the systems for the really huge industrial applications we all know, and which are pretty known in the politics. But the other fact are the small modular ones, which are available in masses in no time and for everyone. That's one factor. And the second factor for a quick energy transition in our point of view. Yeah.
So it is a flexible market. You probably want to continue on that.
Yeah, let me just give one add-on, because I think the point you touched is extremely important. Coming back to Germany, I think the energy transition is not only about replacing fossil energy with renewable energy, but it's also about rethinking the way we distribute the energy. Germany has this big idea of big production centers, big lines, and then distributing it all over the country. And I think that needs to change as well. We need to move to more decentralized, more localized energy grids that then, over the course of the country, are communicating.
So, perfect. So maybe to add to this, or to combine it to what you said, when we're considering, for example, mobility, we are talking about a 10T network across whole Europe that needs to be covered by hydrogen. So when you want an HRS, you first of all need hydrogen. So, and you can't trailer it all from the German Northern Sea down to Bulgaria to get all your cars filled with hydrogen here. So therefore, I think especially a decentral production, yeah, maybe, I don't know, 110 megawatt whatsoever. I mean, the systems we are describing here, like you were describing as well, just support that fast ramp up and are the enabler in order to, at the end of the day, even be able to do a mobility sector with hydrogen, or to replace the generators you were talking about. I think this will really fast up.
And as well, to add one more thing, I think it's also important to make hydrogen, let's say, touchable for all of us, not just for us who know the industry and who know, let's say, the technology. And as well, a good example of that is what at the moment occurs in Switzerland with the hydrogen trucks made by Hyundai, which are floating the market. You need there, let's say, 2 to 4 megawatts of decentralized electrolyzer plants with a refueling station. And that's very good, because all of the people on the road see, okay, that's a fuel cell truck, and that makes sense on the long range.
I'd love to add to that. You saw one of the slides that we showed up there. That is the 1 gigawatt application that we have in Europe, which is all this flooding of trucks from Hyundai. And we are doing power to mobility there. The reason we have chosen to go with cryogenics and liquefaction, which is not always the ideal solution, but in this case might be, it's because that's the way to pack the most amount of hydrogen in the least amount of space. And we actually have done this for 165 refueling stations across the US, because we used to take from the big IGCs gray hydrogen. We are switching that to green hydrogen now, bringing the same shape liquid hydrogen to the deposits that we already had in place, because we had to place all the infrastructure for our customer. Our customer doesn't care about hydrogen, they care about moving boxes, right? So we had to put in the infrastructure, the tanks, liquid tanks, we did evaporators, we did compressors, dispensers, fuel cells into the forklift trucks, and then they can get the mobility application right. Now, Hyundai is doing a fantastic job bringing all these trucks. We have to put those, and with the help of everybody, we're going to put out there all these refueling stations out there. We are bringing 1,000 megawatts, 1 gigawatt of electrolysis to bear, and then we might distribute by liquid, because we have liquefaction technology as well, to all those stations. If those stations are now up and running, and we're going to be working together in this infrastructure, it's not one person or one company is not going to be doing it all. We are taking leaps of faith. We're actually investing $800 million this year to actually put those nodes in the US, and we're making the same type of applications available in Europe with associations like I mentioned earlier, Vaitea, the guys from Renault decided, yes, we're going to do this together. They put the fuel cell into that van, and we now have to refuel those vans. They're starting to go out this year. Next year, you're going to start seeing more and more and more. We have a 50-50 venture with Renault on that one, because we put the fuel cells in there. Now, let's bring the hydrogen to those vans as well. So I think in the end, power to mobility is the tip of the iceberg. The real big applications out there are green ammonia, green steel, eventually even refineries. But for those, we have to get to a price point which is well below the 4 euros per kilogram. It's even below sometimes $2 per kilogram. But for that, you can only do it with scale. And it's not CapEx alone. It's the cost of the green electron that's really helping us all to get it there.
Yeah, no, I just wanted to add on to that because I completely agree with you, right? Like the vision and where we're going towards is green ammonia, making green steel, for example, with hydrogen, right? But when we look at what are those mobility applications that are creating those business cases and those utilization cases, yes, it's refueling trucks, but also what I find quite interesting is these hydrogen hubs, right, that are coming together, whether maritime hubs or airport hubs, because in the end now we're creating the fuel on site instead of having this long supply chain of fossil fuels with losses and emission along the way, and instead we're generating the green hydrogen on site. And then having these logistics centers refueling with hydrogen, either the trucks, the forklifts, but also same case with the maritime ports, where we're also refueling the same kind of setup in terms of mobility on road, but also ships. So I think that will be the medium term, I'd say, use case for green hydrogen as well.
Yes, to add also on Hector, when there are a lot to do when it comes to the industry, to ammonia, methanol, all this, and these are people definitely looking at the numbers, but they're also looking at the image, and that's also a powerful move. So we have a lot of work to do with these guys because they definitely see the equations and can they pass the end cost to the final customers, so to us. That's a key element for them in the economic equation. And there is another field to explore, which is offshore. Offshore electrolysis is just the beginning. People are trying to couple this, to develop offshore electrolysis. And there are very large resources of wind, offshore wind, where large load factors, and this could help also to reduce the cost in the end of hydrogen. So that's, and here we have big efforts, because that's another complexity to make an electrolyzer on the sea.
It's interesting you have these conversations, and one term that has not been mentioned here, which should be mentioned in Europe, particularly in Germany, is energy security. You won't hear German politicians talking about this until recently. They just forgot about the issue. What happens if you are 50% dependent on a source from an autocrat? And if you can turn that up, by the way, the whole plan for Nord Stream, so I was to go around Poland and Ukraine, the predicament we are in is a predicament of energy security. And in fact, democracies actually thrive where their energy security is not at issue. They're not blackmailable. That's one way of looking at the predicament we're in. The other thing is this 50% dependency on natural gas, which has industrial applications. But I think the industrial use of natural gas is about 30%. 50% is domestic heating, and then there's a pile of other things that happen in that equation. That's a rough breakdown of things. That's what we're trying to replace. It's a massive, massive quantity of energy, and it could go off tomorrow. That's one side of this dramatic equation. And whenever we see the dramatic predicament we're in, we look for hope. We should drop, I think, some of the discourse. I'm back to communication here. I hate it when people talk too much about efficiency. You can actually finance a coal-fired electric plant or a gas-fired electric plant that operates 15% of the time. CapEx, why don't they do this for other sources of energy? Actually, that's not the problem. The problem is also energy security. And another issue, just to add to all of this, is the European legislation on emissions. In several cities in Germany, you can sue the mayor when the emissions of fine particle dust, Feinstaub, go beyond a certain level. They need to replace all of these delivery vehicles, the garbage trucks, the postal service with green energy or electrify them. That's absolutely necessary. And that's, by the way, added to that, the buses is where we know things will change. Why is this interesting, I think, from the perspective of the manufacturers of hydrogen? If you ask the guys from Jülich who do the math, they say the biggest bang per buck. You want 4 euros per kilogram, they'll actually offer you more if you get the hydrogen into the bus service. It's the same thing with logistics. They will spend because it's actually affordable. Indoor operations, you don't need 3 vehicles, you need 1 or at least 3 batteries for every unit. It's a very functional alternative. So I don't know whether I've made my inclination here is it's not the efficiency, it's to be more proactive about the absolute need, also in terms of local environmental policies. Aren't they doing things like this in Paris? Aren't there cities where you can't go in without a hybrid car? Isn't it true that in California, if you have a hybrid car, there's a lane for you? Isn't it true that there's something called Cancer Alley? All of the products from China arrive in California, or the large share of them, and they get trucked across the country. And Cancer Alley is a road where all these diesel vehicles drive along the road, and on both sides of the road, basically, or in the vicinity, they have a higher incidence of cancer.
I think you're totally right. At the end of the day, end customers move because of their wallets. They don't move because sometimes ideals just get so far, and then you have to actually start feeling the pain. At the end of the day, you are used in Europe to be paying a lot more for your energy than we are in the US. And we use dirty energy in the US as much as everybody else. But at the end of the day, when you have politicians moving forward and proposing a $200 per ton of CO2 emitted, switches things around. Now it makes a huge incentive to go to these applications, like mobility applications. We can go to California refueling stations and say, here's your kilogram of hydrogen at $10. Okay, I'll take it. Why? Because $10 minus the $4 that you take out from those $200 of carbon emissions tax, now you're at $6. Not so bad. Most applications out there in mobility will gladly take $6 a kilogram. But when you go to large ammonia, when you go to large methanol, large steel, even refineries, then the things get a little more complicated, because if you don't have that tax on it, they will prefer to still be profitable because their shareholders are demanding profits. So at some point, it does have to hit the bottom line. How much are you paying for that molecule? How efficient are you not to use that energy that's very expensive in some places? If you go to Japan, you're paying 20 cents a kilowatt hour or $200 per megawatt hour. Europe, many places you can get it, if you're at the grid, you can get it for less than 70, 80 euros, right? That's why most of our PPAs today are going to be behind the meter, and they're going to be with dedicated sources for green electrons. And that's the only way we can get to the green molecule of hydrogen at a level where you can compete with a gray molecule. I think you're totally right. We need more legislation, more help from governments which are proactive in this sense. But until that happens, the end customer will always choose the cheaper route, or not always, but a lot of times cheaper, because they have to compete with other people, cheaper resources as well. Sad but true.
No one's going to pick that up. Proactive politicians. We're still in this phase of denial where the supply of energy and the risk of energy security has not been really addressed, in my opinion. By the way, this is the distinction between when I talk to the Department of Energy from the United States and then ask them about the European, particularly the German energy security, they just shake their head. How can the #1 per capita exporting country in the world be so dependent upon one source of energy? Not even China will work so closely with Russia as a source of energy because they want their independence. But rather than lamenting that, the simple fact is there may be an absolute necessity to deal with the production of renewable energy and to supplant the supply of natural gas.
But you already took the first step, though. I mean, Germany was the leader by far in wind and solar, has been for a long time in Europe. You have already, how many of your electrons in the grid at any given time are green? I mean, you could do in the high 80s if you want to. At the end of the day, is not becoming the generation of electrons that you need, is the storage of those electrons. I think hydrogen is the best way to store them. I think that pipeline is an ideal way to do it. I think you could start switching your methane lines for pure 100% hydrogen lines. It's not that expensive. You already have the right of way. It's the easiest way, the cheapest way to move the molecule 600 miles or 1,000 kilometers for 15 cents of a euro. You can't do it cheaper with anything else. So I think Germany has a way ahead of the wave in doing this. It's just the willingness of the government to do it, right? So
I don't want to interrupt you, but I can't. This is counterintuitive, isn't it? Here is a German-based hydrogen fuel cell fan supporting the American policies to some extent and doing the reverse. You know, Germany is way ahead. But Hector, let's dampen the actual situation here. Altmaier, what did he do? He made it impossible to build wind turbines close to communities. And these communities would be super small. It was almost impossible. He decimated, to all intents and purposes, the wind turbine industry. It was a growth industry, and it was really flattened. Now, all of a sudden, we know that there's going to be a massive increase of renewable electrical energy, and we're going to have to do something with it. That is not driven by the policy we know in the past. It's driven by the changes that have taken place so recently, and they're going to be massive. They're going to be simply massive. You want to say something? Sorry.
Yeah, want to add on that. You've mentioned wind turbines, of course. That's a huge opportunity for all of us to get very much more renewable energy installed in Germany too. But imagine what can be done if you add on all the empty roofs and place solar on them, and imagine what amount of energy can be produced on every roof available. And that adds on this decentralized vision where we might have like streets or small communities or just some neighbors teaming up, producing their own hydrogen, storing their own energy, and reusing it whenever they need it, even plug it into their cars. That's a huge opportunity that's coming up if once people start to rethink their own, as you said, strategy of using energy. How do I see energy, and how will I use it? Shall I team up with my neighbors, with my streets and my villages, whatever? There's huge opportunities, and time has come to use those.
And the calculation of where those opportunities lie, it's so interesting. I mean, Hector, you've been around for a long time. Some of you have been here for decades visiting this fair. We used to, well, back in 2004, there's going to be at least 100,000 fuel cell cars on the road. Everyone talked about the car because you all like to drive in Germany. Everyone was talking about the car. In the meantime, the most viable market for these very, very small manufacturers who were so desperately in search of a business model, it was the forklift truck. We failed to recognize that the thing that's in your face, which would be an automobile, let's face it, is not always the best way to launch a market, and subtly, year per year, we've developed a solid market for PEMs, for fuel cells, which require hydrogen, and it's increasing. When I say it's increasing, where are the big buyers these days? Trains, can you imagine? Or can you sail into a fjord in the Scandinavian countries with a diesel-powered ship? No.
But wait, because you have trains in Germany again, Alstom trains, which are now powered with hydrogen. And we participated in those infrastructures 3-4 years ago already. At the end of the day, when you're going to have high use of mobility, that's where you can actually justify hydrogen today versus batteries. You don't have to be recharging it for 8 hours or 10 hours. That's how we make our business case in the forklift trucks that you mentioned. We have to come in and compete with batteries in a 3-day shift. When you have 8 hours a day running like crazy with a battery, the last hour just dies out. Well, and then you have to replace that battery with another battery that was charging for 8 hours. With hydrogen, we take 2 minutes, refuel 1 kilogram of hydrogen, you go another 8 hours to the last drop, and then you refuel again in 2 minutes. That is productivity where you're actually switching for. People are not even thinking, oh, this is going to be great and clean. They're thinking, oh, my pocket is getting lighter because I'm using batteries. Maybe if I switch to something else, I can actually make more money because of it. So it's, again, unfortunately, the driver has been money. But we have to make a business case on what our customers listen or what our customers respond to, which in this case has been productivity. So we come in and say, okay, you don't have to wait 29 minutes in changing that battery for that other heavy battery back there that you've been charging for 8 hours, and you don't have to have a load bank of electricity coming to your facility. No, here's your refueling station, we'll put it in, here is your forklift truck with a fuel cell, just run.
But I think talking about mobility and price-wise, what you were mentioning, so it's not only ships, it's also trucks and buses, I think, that are where we have a use case because of the higher efficiency or you don't need to refill it for 8 hours with a battery, something like this, yeah. And furthermore, after the delegated act of the RED II that has been announced, I think 2 weeks ago, something in Europe, there's also a business case, even as of today, for green hydrogen filling it into mobility by creating certificates, by creating quota. I mean, this is a price point you didn't even mention right now, yeah? I mean, we're talking about, I don't know, 7-8 euros or 6 to 7 euros per kilogram that a truck provider or like a company doing truck services would pay for hydrogen. Yeah, then you have the production costs, but if you then add the quota that you generate into that calculation, it's even a business case as of today. So, but the first project must start, and they are about to start as far as we see right now. So, this is how this is all going to gain speed throughout the whole European Union, I think.
Buses, you mentioned that, but buses, when you have buses with batteries, you have to take off 2/3 of the people to fit in the battery, and you're carrying around with this heavy battery all over the place. If you do it with fuel cells, and we have it in California, in Berkeley, running buses all over with fuel cells, well, at the end of the day, you have all that space that you can use to move people, and you have 24 to 32 kilograms of hydrogen on top of that bus, and it refuels in 15 minutes. So at the end of the day, you're right. It's when it's heavy use and long duration of a use of a fuel cell, it immediately justifies a hydrogen instead of a battery.
And the planes. I had to add that one as well. Yeah, the planes. I mean, they're coming, right? By 2026, I think ZeroAvia is planning on having its 80-passenger aircraft, right? So those are already flying, and so I think that'll also be a big utilization also for hydrogen.
And what
It's very
about
light.
refueling stations and infrastructure here? Everyone, well, we're all anticipating at some point there's going to be a hydrogen grid. By the way, when politicians talk about hydrogen, they talk about pipelines, massive ones. I think they're like 3 steps down the road, right? But it's very interesting that some of you have pleaded for a policy of local production and consumption. This involves like the energy grid equation as well as, and here's the question we had years ago, why not a locally powered refueling station? People were working on these things. Automated, you have solar panels or a wind turbine and it fills up hydrogen tanks and people tank up. And these can be, because we need this grid in order to mobilize, if you want to talk about cars, you know, buses and things like that, they use routes where it's easy to service a whole highway. You want to take a whack at this question, it looks like.
Oh, yeah, I mean, why wasn't it used in the past? Yeah, I think there have been approaches for that, as you explained, but these were rather small HRSs. So I think it's 10 to 20 kilo that an HRS currently serves, at least in Germany, as far as I'm concerned, roughly. But when I think when it makes sense is the heavy-duty industry or mobility which you will serve with hydrogen. And we are talking about these systems. I mean, AFIR recommends, I think, 2 tons per day, something like this. They are even talking about 4 tons per day, 5 tons per day. Okay, first we can wait for the pipelines to be ready. Then we can start with our mobility in 20 years maybe. So the second choice is that you trailer the hydrogen, but then you have to have 5 trailers per day going back and forth, and they don't get the hydrogen for free. So they have to have this advantage in the big electrolyzers with the production costs over the decentral generation of hydrogen. And this is why we see a business case in that it makes sense to have the decentral production if you're talking about 2, 3, 4 tons per day or something like this. But therefore, you of course have to think your product one step further from the customer side. What does your customer want? What does your Shell, BP, Total want from their refilling station and from the electrolyzer they have at their place?
I think you go back to one thing. What's the cost of the electron generated in that decentralized location? Because if you can get the cost of the electron, say, I don't know, at 20, 30, 40 euros per megawatt hour, you might have a business case right there, right? At the end of the day, we can scale up our plants and we can make tens of thousands of electrolyzers, fuel cells, whatever. But if you don't get that electron cheaply, decentralized in each one of those communities, houses or plants, you can't reach a price point for that molecule of hydrogen that will be suitable to justify switching. So that is the real conundrum right now. And I think the reason we're all here, yes, because we're great companies and we did great things. No, we also got a huge help from the solar industry, from the wind industry, dropping those costs of electrical power behind the meter. Now, if we don't have this help from, once again, legislation to allow us to take behind the meter electrons and turn them into molecules of hydrogen, it's going to be extremely difficult. If you have to go and pay that tariff that's already established, that's going to be a big, big problem. And one more thing is, we have tax incentive credits, for example, when you're going to make investments like this in decentralized locations. We have microgrids popping up left and right. Yes, at the end of the day, you need to have those incentives in place, but incentives go away. Taxes don't go away. Taxes usually go up. So I think our best
taxes.
Yeah, yes, exactly. So I think in the end of the days, we have to be able to adapt and play with the rules that are established and try to motivate our legislations to allow us to take those electrons from behind the grid. And also, when we were talking with Alstom for the trains, you know what the biggest problem was? Why we were able to put electrolyzers in there? Not because it was cheaper than bringing the trucks of hydrogen, but because the trucks of hydrogen were not allowed to pass through communities that were sleeping communities for people who didn't want to have just like people don't want to wind turbines sometimes out there. They didn't want a hydrogen truck with incredible amounts of energy passing through their community. We have to educate those communities, and we have to educate the legislation to allow us to bring those trucks in. So then we have to put an electrolyzer instead and play with an electrolyzer. That way you don't have these 60 trucks coming back and forth through those communities. So at the end of the day, it's every time is regional and it's local, and legislation has a huge role to play in this one. Can't avoid it.
Yeah, standardization. When we did an exhibit in Nevada, or was it California? I think it was California. I think you were there. There was a discussion about fueling stations. You had to go to the local fire department in order to get permission to install a fuel station. Standardization is very important. By the way, I often wonder whether that is the key for modular construction. You certify the module, and then you can use it in series. I'm not sure whether that is the case. You were shaking your head. Okay, so there's one explanation there. When we started ages ago here, we had a direct methanol fuel cell, and we couldn't bring it in the building. We explained to them that the exhaust of this fuel cell was like a human breathing, even less. But there was no standardization, so you couldn't get permission to bring it in. Then we had a fuel cell running on a tank of hydrogen. We couldn't get it in the building. This is how far we've come, but yet how far we've got to go. And I suppose that's another question, you know, how much legislation is still in the way? How much certification is sort of a gray area where we're waiting for things to happen? I see some people nodding their head. If you don't have an answer ready, I'm going to ask the audience if they have any questions they'd like to ask. We do. I hope you don't mind.
So I think the discussion is very interesting. The question I have, we talk about a lot about electrolyzers, using converting water into hydrogen. And we talk about the electricity, renewables, but we are not talking about the water. What about the water? We know that in Australia, the water is expensive. It's not a free resource. And removing the salt from the sea, I think it's not something that is acceptable from an ecological point of view. So this primary resource is not even told or discussed here. I would like to have your opinion on that.
Yeah, I think it's a great question. I would start us off, and whoever wants to build up on it, like, please be my guest. I think one point on this, and you're absolutely right? Water is a finite resource. However, when you look at the water consumption from fossil fuels, no one's talking about that either, right? So let's just start with that. But also, when you look at how much energy you're getting from the water for the quantity that you're using, it makes total sense for the need that we have as well from an energy perspective.
And so what happens when you burn hydrogen in a hydrogen fuel cell car? What comes out the exhaust pipe?
Water. It is pure same water. So that's the thing. It is a great question, by the way. I'm not trying to put you down on that. I think it's a concern. Most people say, wait a second, we're going to put an electrolyzer in the middle of California. California is fighting for water, north versus south, and all those things. Guess what? How much water do we need for 1 kilogram of hydrogen? Okay, we need 9 liters of water. 9 liters of water, stoichiometrically speaking, to produce 1 kilogram of hydrogen. Great. At the end of the day, that water comes back to you when you pass through the fuel cell. How does it come back? It comes out to the tailpipe. And in that use of a fuel cell, you're getting that water back in vapor water. Vapor water you can capture, you can drink it. It's not great for you because it doesn't have any minerals, but you can drink it. Okay? That goes up in the next cloud and drains again. So at the end of the day, we're a full circle of using. You can think of water as your battery, without the lithium ion. So at the end of the day, you're breaking that molecule of water and you're putting it back together. So you're not really using that water.
Are there any other questions? I think we're almost out of steam here, although it's just getting interesting. I know you're all thirsty and the drinks are waiting around the corner here, and I apologize for drilling you, but when I look at there's a visionary point here. I mean, the people on the stage here and their industry are really going to save our butts. We need renewable energies. We have to phase out fossil fuels. People talk about the CO2 emissions. I prefer to talk about the global warming catastrophe and the implications of methane and the whole equation there. But the bottom line is we're facing a huge challenge. And we say that there's ways to get toward the next step. We're moving very slowly. People recognize that. We need to move much more quickly. I kind of think if you're a skeptic or a cynic, what you may believe is, let's look at the countries that have done a better job. In Norway, they have hydroelectric energy. They got lots of it, right? So where can you refuel an electric car for free? The idea is what may drive the change and what may need to drive the change is an excess availability of renewable energy, right? And then it will force the optimization, even, by the way, in cases where, since 1928, what have our friends at Nel been doing? They've been putting hydrogen into the natural gas grid. What are they doing right now? It took like a century to get to that point, but in England right now, they're stabilizing the grid, and if they have any excess, they've got permission to put at least 10% hydrogen in the natural gas grid, which is larger than the electrical grid in terms of its kilowatt carriage. So I don't know whether you agree or disagree, but the idea is what may be driving the equation is going to be policy towards creating renewable electricity, and then your market is going to boom.
So I think regarding renewable electricity, it will lead to, definitely you have more electricity available, but it will also lead to having higher fluctuations. So I mean, there will then, if the sun doesn't shine and the wind doesn't blow, you then have less at these times. And then you have other times in the day when you have really an overload of electricity. So this is actually happening as of today, but this will increase by a factor if you have more of this electricity. And therefore your demand has to adapt to that. And I'm convinced that the prices as they are currently at the spot market will be more tangible also to you as an industry customer, as an electrolyzer runner or operator or whatsoever. So you run your systems when the electricity is for free or when it's cheap, something like this. So you have to do some load balancing on a national grid somehow. I cannot tell if electrolyzers are the perfect solution for that, because it will reduce your total run hours per year, which has a high impact on the price of the kilowatt hour if you're having too high capex on your system. But this is definitely something where the energy transition will lead to, and I think where we will have to find an answer, and I think hydrogen can be one part of the answer.
So I agree with you, Hector, I don't want to interrupt. I agree with you, but I always say, let's be clear. If you take the energy budget as a pie, the electrical grid, which is always the mistaken focus of our debate often, is only 15% of that pie. Everyone refers to renewable energy primarily as something that goes into the electrical grid, but we have to make up for the 85% of energy that is non-renewable, and that's why I think issues of grid stabilization, no, we got to get to storage and distribution beyond the quantity of energy that is absorbed via the grid. Hector, you wanted to add something.
No, I agree with you. At the end of the day, I wanted to build on what you just said. At the end of the day, we have not only the wind and the sun and even hydro providing us energy, sometimes when we don't want it, so you can take that excess energy all the time, yes. But you also have the nuclear energy. I mean, look at France. You have a baseload nuclear, but your demand goes like this. So you're not always taking that baseload. You have all this excess energy. What are you doing with it? That is also energy that we should utilize. And how do we store it? How do we store it in gigawatt scale, gigawatt hour scale? I think the only way to store it, or the best way to store it, is in gaseous form, because it's compressible, and it could be in those pipelines that you already have. So the pipeline is the distribution network at the same time as being your storage tank, huge storage tank. So we got to start switching those methane lines for pure hydrogen lines. And technology is available. It's not that expensive, and you already have those right-of-ways. I'm not against the microgrids, by the way. I think microgrids are a fantastic way to go, especially when you're far away from any other source. Fantastic. We should continue developing those. But if you're talking about storage, and you said 85% of the energy is not electric, sure, that storage could be placed at the right place, which is the pipeline, coming from offshore or already installed in Netherlands, Germany, etc.
This is, I don't want to, no concluding word here, but why it's interesting to downplay the myth of efficiency is because burning natural gas, the guys at Air Liquide 2 years ago told me they cry every time they hear someone burns natural gas. But it is a use, an interim use, while we build up capacity. And it's inevitable that not optimal use is going to transpire. It's great if we can fuel nothing but buses and trucks. but there's going to be a mixed bag, I'm sure, as things expand. Is there anything you gentlemen would like to add, sorry, ladies and gentlemen would like to add before we conclude?
Yeah, I'd like to add a small example of one of our customers who's already building up a huge campus just for using excess energy out of the grid in Texas. They are building up systems that are only running with excess energies, and they are not doing this for free. They are doing this as a huge business case and want to earn lots of money, and they will do that. So that's a really good perspective, not just producing green hydrogen or whatever, but yeah, switching to fluctuating loads in huge amounts. That's also a possibility, and adds on this topic. And you can combine those loads with hydrogen production or whatever is needed. Yeah.
We actually began with this. Where efficiency counts, by the way, I don't want to say it's not important. I think it's exaggerated to our detriment because we're being compared with even less efficient technologies. And we have to, as engineers, I'm not an engineer, so as engineers, you should be aware of when that's happening and object to it. But the efficiency things, like for instance, Stéphane was commenting on if you're trying to recoup renewable energy, you need fast reaction times, and it has to be efficient over various loads. It can't start operating when you get to 40% of the maximum power. So they are super important in and of themselves. But the equation of how energy is being used when we have to scale up demand so radically is...
I think everybody here uses a PEM technology, and if you go back 10 years ago, well, sorry, AEM, but it's like it's the alkaline PEM at the end of the day. Well, the ones that I know, and I'm not as well versed in your technology, but I'm getting there. The ones that I know that can react fast, really fast, in milliseconds, to that changing load, is really PEM and possibly AEM as well. So at the end of the day, this is the right technology. All of these presenters here is the right technology to bring and actually get all the full load hours that you can get out of a wind turbine or a solar panel. As soon as it's available, you can take it out. And that's why we always count. We don't know when the wind's going to blow. We don't exactly know when the sun's going to shine, but we know it's going to be 4,320 hours a year. Okay, we grab that, and that's how we built our business case. Yes, efficiency is important, but it's more important to know that you can get that electron, green electron, for a whole year at a certain price point. That was the biggest challenge at Plug we had when we built those plants in the US and how we were building them. First, we went and negotiated the PPA agreements for the green electron, then we go build the plants, not the other way around.
Okay, with that, we're dry. We're ready for a drink here. I'd like to invite all of my guests to come over, and then you can join us and continue the conversation. We've been talking to Matthias Kramer, who is CFO of Hoeller Electrolyzer, and Dr. Max Ellerich, who's Technical Director, Neuman Esser. I'm not sure, is it NAE Green?
NAE Green.
Oh, okay, NAE Green, and Ulf Jörgensen, who is H-TEC Systems, Alexander Detke, Technical Sales Manager, H-TEC Systems, Vaitea Cowan, who is co-founder and head of communications at Enapter, Stéphane Maillard, who's sales director at Elogen, and Hector Massa, who is VP sales Plug Power. Used to be Jenner, now it's Plug Power.
But not sales anymore, strategy and products.
Okay.
used to be sales.
Sorry. Thank you for your patience and your time. Join us in a continued conversation. Great to have you here.
Thank you.